Imagine a computer that monitors its own exhaustion, right? Like it spots potential crash coming and then silently writes its own custom diagnostic tools to survive.
All because you gave it like a one-sentence vibe.
Exactly, just a vibe. And today, that is not science fiction. That's just, a Tuesday on a Raspberry Pi. Welcome
Yeah.
to the deep dive, everyone.
Yeah, glad you could join us.
Our mission today is to really explore this massive paradigm shift in how we interact with our hardware. We're looking at this fascinating post from tech-reader.blog.
Written by Aaron Rose, right?
Yeah, Aaron Rose, dated July 8, 2026, and it's titled Raspberry Pi Vibe Coding Number 1.
Catchy title, honestly.
It is. And we're breaking down how to leverage these modern AI models to custom build system tools from scratch, specifically a CPU load dashboard.
And doing it without manually writing a single line of syntax yourself, which is just wild.
Not a single line. Okay, so let's unpack this for you listening. Think of this deep dive like a master class in becoming a tech architect.
I like that analogy.
Right, because instead of laying the bricks yourself, you're learning how to draft the perfect blueprint to just hand off to an AI builder.
It represents a complete inversion of how we've always approached software.
Yeah.
I mean, for decades, if you needed a highly specific utility for a project box,
You were kind of stuck.
completely stuck. You had two choices. You either spent hours writing and debugging a bash script yourself.
Pulling your hair out over a missing semicolon.
Oh, always. Or, you scoured GitHub, just praying someone else had built something that vaguely matched your specific hardware setup.
Right.
But now we're moving from this world of manual labor to a world of rapid orchestration.
Rapid orchestration, I love that. But before we get into the mechanics of how these, July 2026 AI models are actually pulling this off, we have to look at the canvas we're painting on here.
The hardware.
The hardware, exactly. Aaron Rose specifically targets the Raspberry Pi in his article. And the hardware heavily dictates the approach we have to take.
Oh, it dictates everything. If you look at the 2025 and 2026 hardware landscape detailed in the sources, the Raspberry Pi occupies this incredibly vital space in edge computing.
Yeah, edge computing is huge right now.
It is. So you might be running an older Pi 3B Plus as like a home DNS sinkhole, or maybe you drop the cache for the newer Raspberry Pi 5.
Which is a beast, by the way.
It is a serious piece of silicon. We're talking about a quad-core Cortex A76 processor.
Running at, 2.4 gigahertz?
Exactly, 2.4 gigahertz, and it's paired with up to 8 gigabytes of LPDDR4X RAM.
See, I look at those specs and I immediately think about standard consumer laptops from just like a few years ago.
Oh, absolutely.
That is a massive amount of overhead for a single board computer the size of a deck of cards.
It's a massive leap in raw compute, sure, but, and this is key, that power is kind of deceptive.
How so?
Well, the article highlights a crucial limitation. The Pi 5, for all its processing capability, it still lacks the specialized hardware acceleration you'd find on high-end desktop GPUs.
Or like dedicated neural processing units, right?
Exactly. So when you deploy a Pi as a headless server or an IoT array, you are constantly battling resource management. Constantly.
Even with 8 gigs of RAM.
Even with 8 gigs. Because if you try to run local computer vision tasks or, heavy data streaming, that 8 gigabytes vanishes fast.
So memory bandwidth is still a severe bottleneck.
Always.
Okay, I want to push back on that a little bit because the sources also dive into this whole minimalist's dilemma.
Right, the OS showdown.
Yeah, pitting Diet Pi against Raspberry Pi OS Lite. And both of these are stripped-down operating systems designed to avoid GUI bloat entirely.
Which is the standard practice for edge devices.
Sure, but if I have an 8 gigabyte Pi 5, why am I forced to penny pinch my resources with a plain text operating system? Like, can't the hardware handle a standard desktop environment while running background scripts?
I mean, yes, it can handle it, but the question is whether it should.
Okay, fair point.
When you run an X11 or Wayland desktop environment, you aren't just taking up static RAM, you're demanding constant context switching from the CPU.
Context switching, meaning
the processor has to constantly interrupt your core workload. Say you're processing an incoming video feed for a security system.
Right.
The CPU has to stop doing that for a microsecond to redraw the mouse cursor, or update a graphical clock, or maintain a Windows state.
Ah, I see. It's distracting the driver, basically.
That's exactly it. Even a millisecond of latency introduced by that graphical overhead can cause packet loss in high-throughput edge applications.
Wow. So it's not just about running out of space in the memory warehouse, so to speak.
No, it's about the speed and focus of the processor. A GUI constantly distracts the CPU from its primary mission.
That makes a lot of sense. You want the processor dedicating like 99.9% of its cycles to the actual task, not to rendering the pretty dashboard that monitors the task.
Precisely. And this constraint is exactly why Diet Pi and Raspberry OS Lite boot straight to the command line interface.
The good old CLI.
The CLI remains the gold standard for pure, unadulterated efficiency.
But, and I think this is where the article really shines, that efficiency creates a really steep barrier to entry for most people.
Oh, incredibly steep.
Because if you strip away the graphical interfaces and you get rid of all that bloated off-the-shelf monitoring software,
You're left completely alone in the terminal.
yeah, it's just a blinking cursor. And you need hyper-efficient, bespoke tools to monitor your system, which traditionally meant you needed to be an absolute expert in Linux shell programming.
Which brings us to the core concept of Aaron Rose's tutorial, doesn't
It
it?
does. Vibe coding.
Vibe coding. It's such a great term.
It really is. So the specific project he outlines is a CLI dashboard for CPU load. And it's just this tiny custom shell script.
It simply calls the built-in Linux uptime command.
Exactly. It calls uptime and prints the 1 minute, 5 minute, and 15-minute load averages. That's it.
And the philosophy he adopts here is beautifully focused. He writes, quote, just one thing, just one script, just one
I
winner.
love that. Just one win.
The intention is to spot when the processor is struggling, before the thermal throttling kicks in, the whole system freezes up.
Right, because once it freezes, you're done.
Exactly.
Right.
But what's really fascinating here is the contextual timing of this workflow. We're looking at July 2026.
A great month for AI.
Truly. Anthropic just launched Claude Sonnet 5.
Yep.
And API access to Fable 5 was just restored.
Okay, let's talk about those models for a second, because I feel like we need to address the elephant in the room. Earlier AI iterations were notoriously bad at this kind of thing.
Oh, they were terrible.
If you asked a 2023 or 2024 model for a bash script, you'd often get like hallucinatory syntax or completely deprecated commands.
Or bizarre loop structures that caused way more problems than they solved. I've bricked a few test environments that way.
Right. So for you listening, if you've been burned by AI code before, you're probably skeptical. What is happening under the hood with Sonnet 5 and Fable 5 that turns them from these unpredictable text generators into perfect translators for vibe coding?
It's a fundamental shift in how the models operate. They now map semantic intent to deterministic syntax.
Semantic intent to deterministic syntax. Break that down for me.
So older models were essentially highly advanced predictive text engines, right?
Like the autocomplete on your phone, but on steroids.
Exactly. They guessed the next most likely token based on vast, generalized internet data. So if your prompt was slightly ambiguous, the probability matrix would drift.
Meaning it would get confused.
Right, and it would generate code that looked correct to a human but functionally failed when you actually ran it.
Because it was guessing, not thinking.
Yes. But the July 2026 architecture behind models like Sonnet 5 represents a move towards semantic compiling.
Okay, semantic compiling.
They've been rigorously fine-tuned on the actual topological structure of Linux kernels, and they understand the strict rules of POSIX-compliant scripting.
So they actually know the rules of the road now.
They do. When you give them a plain English vibe, they aren't just predicting the next word anymore. They are actively parsing your intent through a validated syntactical tree.
Wow. Okay, here's where it gets really interesting for me. I love the idea of using these new models specifically to build a CPU load dashboard.
It's the perfect use case.
It is, because monitoring CPU load on a headless server, it's exactly like watching the RPM gauge on your car's dashboard.
That's a great analogy.
Right. Like, you don't need to be a master mechanic to commute to work. But if you look down and see that RPM needle redlining into the danger zone,
You know you need to ease off the gas.
exactly before the engine blocks warp and you're stranded, that's what this script is doing. The 1 minute load average, that's your current RPM.
Yep.
And the 5 and 15-minute averages tell you if you've been, driving up a steep mountain pass for the last 10 miles.
That analogy perfectly isolates why these specific metrics matter so much. Because a momentary spike in the 1 minute average, that's normal.
Right. Maybe a cron job just executed.
Or a sudden network request came in, the system revs up, handles it, and calms down.
They're a big deal.
But if your 15-minute load average is sitting at like 4.0 on a quad-core Pi, yeah, that means every single core has been pegged at maximum capacity for a sustained period.
Tasks are just queuing up.
Exactly. Your system is legitimately drowning. And you need a lightweight tool to flag that reality for you instantly without adding to the burden.
Okay, so we understand the hardware constraints. We know what tool we need to build, and we know these 2026 AI models are finally capable of writing deterministic, functional bash scripts.
So what's the catch?
The challenge now is communication. How do you, the listener, translate your abstract need for an RPM gauge into a prompt that guarantees you get a hyper-minimalist CLI tool?
Rather than a bloated, over-engineered mess.
Exactly, because AI still wants to be overly helpful if you let it.
This is where the methodology in Aaron Rose's article becomes critical. The transition from an idea to a functional script, it requires an entirely new discipline.
The art of the prompt.
The art of the prompt. It requires prioritizing absolute precision over conversational poetry.
The tutorial breaks this down into a highly specific life cycle of collaboration, and I found this fascinating. The first two phases don't even involve the AI.
Right, it's all internal.
You have to conceptualize the output internally first. You have to visually imagine a plain text return in your terminal.
No ASCII art.
No colors, no interactive marrows. You have to lock in the strict constraints of the CLI before you type a single word into the prompt box.
Which is harder than it sounds.
It is. And then we get to the actual prompt itself. This source provides the exact text Aaron Rose uses. Let me read this.
Let's go for it.
He types, "Write a simple shell script for Raspberry Pi that prints the CPU load averages. 1 minute, 5 minute, 15 minute. No colors, no formatting, just plain CLI output. Includes pseudocode headings as comments in the source code for each major code block."
We really need to dissect the mechanics of that prompt.
Please do.
Because it is doing a tremendous amount of heavy lifting behind the scenes. Notice his heavy reliance on negative constraints.
The no colors, no formatting part?
Exactly.
Yeah.
He explicitly dictates no colors, no formatting, just plain CLI output.
I want to dive into why those negative constraints are so vital.
Okay, how do you see it?
Think of a large language model as a probability engine that naturally trends toward complexity.
Yes.
Because they're trained to be as helpful as possible to the user, their default state is to over-deliver.
They want to impress you.
Exactly.
Right.
So if you just ask for a CPU dashboard, the probabilistic math naturally drifts toward the most feature-rich examples in its training data.
It'll try to build you a whole web app.
Right. GUIs, ANSI, escape codes for colored text, dynamic refreshing every second.
All the stuff that kills the Pi's performance.
Yes. So the negative constraints in this prompt act exactly like the bumpers in a bowling alley.
Oh, I like that.
They physically block the AI's probabilistic math from drifting into the graphical user interface gutter.
That is an excellent way to conceptualize it. You're actively manipulating the probability matrix to enforce the minimalist integrity of your Diet Pi or OS Lite environment.
Keeping the ball in the lane.
Exactly.
Yeah.
But the structural brilliance of this prompt, I think, actually lies in its final sentence.
The pseudocode part.
Yes. Include pseudocode headings as comments in the source code.
Pseudocode being like plain English logic formatted to look like code structure, for those who might not know.
Right. But why is forcing the AI to write pseudocode comments so impactful for what is essentially a super simple shell script?
Is it just for readability?
It's more than that. It acts as a forcing function for chain of thought reasoning within the AI model itself.
Oh, interesting.
By demanding pseudocode headings, you're requiring the AI to overtly explain its logical sequence before it generates the executable syntax for that specific block.
So it makes the AI think before it speaks?
Exactly. It prevents the model from rushing to a flawed syntactic conclusion. Furthermore, it creates a readable map for the human user.
Which is huge.
You aren't just being handed a black box of cryptic symbols.
Yeah.
You're receiving a fully documented step-by-step breakdown of exactly how the script interacts with the Linux environment.
And that documentation becomes absolutely crucial in the next phase of the life cycle.
The execution phase.
Right. So the AI processes the prompt, the bowling alley bumpers keep it in line, and it spits out the raw script.
Success.
You copy it, you SSH into your Pi, and you paste it into Nano or Vim, and you save the file as showsipulo.esh.
Sounds easy now.
Now, human nature dictates that the millisecond that file is saved, you just want to run chmod plus X to make it executable and run it to see your shiny new dashboard.
Of course you do. We all do.
But Rose throws up a massive non-negotiable stop sign here.
He does. And this represents probably the most important philosophical shift in the entire vibe coding process.
It's a mindset shift.
Completely. The article explicitly states, and I'm quoting here, AI usually writes good code, but good programmers always inspect code before running it.
Trust but verify.
Trust but verify. The tutorial demands that you use the more command in Linux or simply read through the file in your text editor before you ever think about modifying the execution permissions.
Why is that so critical?
Well, if we connect this to the bigger picture, this specific step fundamentally alters the user's relationship with the hardware.
Okay, how so?
You are no longer acting as a passive consumer,
Yeah.
right? You aren't just blindly downloading a precompiled binary from a random internet repository and hoping it isn't malicious or wildly inefficient.
Right, crossing your fingers that it doesn't wreck your system.
Exactly. Instead, you are stepping into the role of a senior code reviewer.
I love that framing. It's like, imagine acting as the lead engineer reviewing a pull request from a hyper-fast but maybe slightly naive junior developer.
That's the AI.
Right, the AI is the junior dev. They can type 1,000,000 words a minute, and they usually get the syntax right.
But they lack the overarching systemic awareness of your specific hardware setup.
Exactly. You cannot afford to let them push code straight to production without auditing their logic first.
Because if they mess up, it's on you.
Yes. You have to read those pseudocode comments they provided to ensure they actually called the native uptime command, rather than, say, hallucinating a complex background daemon that's going to memory leak your Pi into oblivion.
Exactly. The AI is the builder, but you remain the architect.
You own the liability for the blueprint.
You do. And only after you have manually verified the logic, only then do you make the file executable and run it.
And when you run it, you finally see those 1, 5, and 15-minute load averages printed cleanly on your terminal line.
Just plain text.
0 overhead.
Yeah.
One tiny dashboard item, one tiny win.
It's very satisfying.
It really is. But Rose also embraces the messy reality of the terminal, doesn't he?
Oh yeah, he doesn't pretend it's magic.
Right. He immediately asks the reader in the article, did you get an error? Because the error is an integral part of the process. It's expected.
Totally. The article points out that debugging is where the real knowledge transfer happens for the user.
So if the script fails, or if it outputs the data in some weird format, you don't start manually rewriting the syntax yourself. Resist the urge to fix it manually.
Exactly. You copy the exact error message from your terminal, you paste it straight back into Sonnet 5 or Fable 5, and you ask the AI for a correction.
You enter an iterative debugging loop.
Yes. Prompt, inspect, execute, analyze the error, and reprompt.
It's a constant conversation with the AI to refine the tool.
And because the AI models of July 2026 have context windows capable of retaining the entire history of the session,
Oh, that's a great point.
the model actually learns the specific quirks of your system environment as you iterate. It remembers what didn't work 3 prompts ago.
This iterative loop is the true essence of vibe coding, isn't it?
It is. It dramatically lowers the barrier to entry for system administration, but it doesn't eliminate the need for systemic understanding.
That's a crucial distinction.
As the sources suggest, the ultimate value isn't just the final script you get.
The script is just the byproduct.
Exactly. The real value is the fact that by reading the pseudocode and navigating that debugging loop, you, the user, naturally absorb the logic of bash scripting over time.
The tool builds your competence while you build the tool.
Perfectly said.
Well, we've covered a tremendous amount of ground here today.
We really have.
Let's quickly recap for you listening. We started by exploring the physical realities of edge computing on the Raspberry Pi.
Right. Why even a powerful Pi 5 with 8 gigs of RAM demands extreme efficiency.
And why GUI overhead is so detrimental to dedicated background tasks. Then we defined the concept of vibe coding, a hyper-focused CLI dashboard to monitor CPU load.
Just one win.
Just one win. From there, we analyzed the mechanisms of modern semantic compiling LLMs and the vital importance of using negative constraints.
The bowling alley bumpers.
To manipulate their probabilistic outputs, exactly. And finally, we walked through the architectural workflow of inspecting, verifying, and iteratively debugging the AI's code.
We've effectively charted the transformation from a passive software consumer into an active, custom tool creator.
It is a profoundly empowering shift, honestly. You are no longer constrained by the tools that exist. You are only limited by your ability to articulate the tools you need.
That's the real takeaway here.
So as we wrap up this deep dive, there's one lingering thread from the source material that I think deserves our attention.
Okay, what was that?
Aaron Rose mentions at the end of his post that the next project in his vibe coding series is CPU temperature monitoring.
Finding a way to track thermals and keep the Pi cool under heavy loads. Makes sense.
It does. But if we follow the trajectory of these July 2026 AI models, I think we need to look past just a simple temperature dashboard.
Where are you going with this?
Think about it. Right now, we are manually prompting the AI, copying the script, verifying it, and running it to check our system's health.
Still a human in the loop.
Right. But how long until the human element is entirely removed from that loop?
Oh, wow.
If an AI can reliably write flawless POSX compliant scripts based on a single prompt today, how close are we to deploying a lightweight autonomous agent directly onto the Pi itself?
An agent that just lives on the edge device.
Exactly. Imagine a system that constantly monitors its own CPU load and thermal dynamics, and when the 15-minute load average spikes and the processor hits, say, 80 degrees.
The agent doesn't just alert you.
No, it instantly vibe codes a custom script to throttle background services, gracefully shuts down non-essential Docker containers, rewrites its own resource allocation protocols, and compiles them in real time.
Without you ever lifting a finger.
Without you even knowing it happened. And once the system cools down, it rewrites the scripts again to spin everything back up perfectly.
That's the logical conclusion of rapid orchestration, right?
Is the ultimate minimalist operating system one that doesn't actually exist as a static piece of software?
But rather one that continually invents and deletes itself based on the real-time physical realities of its hardware.
Yes.
If the system observes itself, diagnoses itself, and perfectly codes its own solutions on the fly, it fundamentally redefines what an operating system even is.
It ceases to be software and becomes like an active, adaptive reflex.
An adaptive reflex living inside a computer the size of a credit card.
It's wild to think about. Something for you to chew on the next time you open up your terminal.
Absolutely.
We hope you feel equipped to fire up your favorite model, leverage those negative constraints, and start drafting some blueprints of your own. Just remember, one thing, one script, one win.
Happy coding, everyone.
Until next time, keep exploring.